Hey guys, today I want to go over the meteorology PowerPoint, so bear with me here. Okay, one of the big ideas, one of the central themes of this unit is the idea of weather versus climate. You can see the definitions here. Weather is the current state of the atmosphere, and climate is long-term variations in weather for a particular area. Basically, what I want you to take away from this is weather is what it's like outside right now. It's the current state of the atmosphere. And climate is weather over a long period of time in a certain place. So, for instance, you would say, what's the weather outside right now? And weather may be a day, a week, a month, a year, but climate is that long-term weather. So what do we see on average for example, today, February 6th, the weather outside is cold and sunny, but on average, it's usually cold and sunny on February 6th. So what it is today corresponds with the climate of the general area. The definition of meteorology here is the study of weather on the surface as well as in the atmosphere. Okay, and what it causes weather? Well, it's wind systems that are flowing from areas of high concentration to areas of low concentration. And we talked about that being a central theme in science, is that most things go from an area of high concentration to an area of low concentration. And it's no different from wind here. Okay. While naming wind systems, one thing that you need to keep in mind is that they are named from the direction that they come from. So a northeast wind means that it's flowing from the northeast to the southwest. So the arrow is going to point to the southwest, but know that it's a northeast wind because it's coming from the northeast. So its starting point is where it's named from. Okay, just so you know, the jet stream is a high altitude wind current. All right, here's some instrumentation that we use to measure weather on the surface of the Earth. You've probably heard of at least a thermometer, but a couple of the other ones here, a barometer, an anemometer, and a hygrometer. You should all know that thermometers will measure temperature, but the other three, you can see those here. Barometers measure the air pressure, hence the name barometric pressure. You have an anemometer, which measures wind speed, and a hygrometer that measures the relative humidity. However, we can also measure weather from the atmosphere, and we use a weather balloon to do that and a radiosonde. And here you can see a picture of the instrumentation used in a weather balloon and an example of the data that gets sent back to the surface. You've probably heard of Doppler radar before, but it works kind of like echolocation does in dolphins, whales, and bats. Basically what happens is the antenna sends out a signal, and then that signal bounces off something, and the distance away that it is from the radar dish, is measured and calculated, and eventually gives you a picture that looks kind of like this. This map should look familiar due to the weather tracker activities we've been doing. So we're going to go over a little bit of that now. Now, the second biggest theme of this unit is air masses. Okay, and an air mass is a large body of air that takes on the characteristics of the area over which it forms. Okay, and air masses are classified according to their source regions, just like wind patterns. Okay, there are 5 major types of air masses, and I don't need you to memorize these. Just know what the words mean, and it'll explain where it comes from. So the words you're going to see are things like dry, warm, continental, tropical, humid, maritime, cold, polar, and Arctic. You should all know what warm and dry mean. You should all know what cold means. We can go into some other ones. Humid is going to mean wet. Maritime is ocean. Continental, land. Polar comes from the northern regions. Tropical from near the equator. Polar can either come from the north or the south poles, and then Arctic from the Arctic areas. So if you put those all together, something like a warm, dry, continental, tropical air mass, I'll know that it's warm, it's not wet, formed over land, and it came from near the equator. Something like a cold, humid, maritime, polar, I know that it's cold, it's wet, it formed over the ocean, and it came from near one of the polar regions. So using just those words, I can tell where these air masses formed, where they came from, and what their characteristics are going to be. Keep in mind that all main 5 types of air masses can be found in North America, and this map shows it. You will see this map on the final exam. Get used to it, but keep in mind that I already explained to you that just using those vocab words, using the title of the air mass itself, you can determine and decipher where these came from. So you don't have to memorize this map. Just know that you will see this again. Okay, we've already been talking about fronts doing the weather trackers, but we'll go over that here. It's basically a boundary between two different air masses that'll bring stormy weather with it. And we'll roll through these. How do we recognize what a front is or where a front is? Generally, it'll be characterized by sharp temperature differences. For example, here, you can see a cold front is a boundary between a cold air mass and a warm air mass. Basically, what happens is the cold air pushes the hot air out and is replaced by cold air. You can see that by the temperature readings here. You see the warm temperatures here and then being replaced by the colder temperatures here. And of course, you know that the blue is the cold front. Here is an example of that. Okay, a warm front is the opposite of a cold front, where colder temperatures are pushed out and warmer temperatures replace those. You can see that, and we should know that this symbol characterizes a warm front. A stationary front is a boundary between two air masses that more or less doesn't move. Basically, they hit each other and they just kind of sit there. And we know that that's characterized by the alternating cold and warm front symbols. And an occluded front is basically where a cold front catches up and overtakes a warm front, hence the combination of the two in the purple color. You'll have the blue cold front and the red warm front that mix to form the occluded front, which is purple. A trough is an area of relatively low pressure that usually brings a lot of rainy weather with it, and we notice that as those black lines, those black dotted lines on the surface map. Isobars are kind of like contour lines on a topographic map. Basically what they do is connect areas of equal pressure. So just like contour lines, the steeper or the closer together that they are, the more drastic the difference, the more high winds you're going to occur at that location. For example, here you can see all the high winds from the steepness of the lines close together here as well as here.